Our universe has been growing ever since the Big Bang, which is said to have been the beginning of everything. However, what lies on the other side of the cosmos? The universe must have an edge if everything started from a point that is currently growing. Furthermore, if there is an edge, something must logically be beyond it. Which of the exciting methods that science offers to get us closer to the end of the world and the afterlife is correct? It was once believed that the world terminated at the horizon, and that anyone who reached it would unavoidably tumble off the edge and vanish. But as they traveled farther and farther, a few inquisitive individuals discovered that the world's edge was moving in an intriguing manner with them. However, it wasn't until thousands of years ago that mankind discovered the world was round. For a long time, there was a persistent sense that the world was ending. Once more, the Earth was a disk, and anyone who approached the edge too closely would be lost forever. People believed that this goal existed beyond the seas, and that it was best to avoid sailing too far out when the land masses were better researched. Only Columbus set out for America after realizing this was all nonsense. People have since realized that their Earth is a spherical with no actual beginnings or ends. In any event, no one gets lost. They are free to run as far as they choose. The modern cosmos is no different. We see a conclusion when everything must stop and nothingness or voidness arises, but is that actually the case? To what extent is the cosmos expanding? It may sound absurd, but scientists now think they can demonstrate that the universe we live in today began as a tiny point, little bigger than a seed. The universe has been growing ever since. According to the majority of scientists, expansion is what creates the space that existed before the Big Bang, not the universe expanding within it. However, this must take place in a space or medium in our imagination. We don't yet know what that might be. In addition, we are unsure of the universe's actual size and whether the Big Bang actually occurred. This effectively means that we are unable to observe the universe's temporal or spatial end. Theoretically, humans are also unable to see past the margins. Or are we able to? The issue of the edge's non-visibility is being tackled by scientists in several ways. The portion of the cosmos that we can identify and investigate using the tools and techniques of modern science and technology is known as the observable universe. It is determined by the farthest that light and other electromagnetic radiation have been able to travel since the Big Bang. The limited speed of light, which is roughly 299,792,458 meteors, according to Einstein's theory of relativity, establishes this limit. The cosmos Hubble believed that light would never reach us beyond this horizon because it would spread so rapidly owing to cosmic expansion. The Hubble constant, which shows the rate of expansion with respect to distance, was used to calculate this. The Hubble constant is currently estimated to be about 70 km per megaparsec, with 3.26 million light-years being equivalent to 1 megaparsec. The researchers came to conclusions about the regions outside the visible universe based on this data, which we have received from observations within the visible universe. This does not, however, always produce results that are genuinely consistent. Although it hasn't been demonstrated by actual data, the Hubble horizon is merely a notion that can be somewhat comprehended analytically. We do not yet know the true cause of the Hubble horizon, or whether the Hubble constant acts uniformly throughout the universe. Another essential element for getting close to the universe's edge is light. Our understanding of the cosmos is fundamentally constrained by the speed of light. One might assume that the observable universe has a radius of 13.8 billion light-years because it is thought to be around 13.8 billion years old. This is untrue, however, as the universe has expanded since the Big Bang, so that the observable cosmos has a total diameter of over 90 billion light-years with a radius of about 46.5 billion light-years. We perceive the past and the light from objects that were considerably closer than they are now when the light was emitted, which leads to this seeming paradox. This is due to the fact that the light allows us to see long-gone space images. We can only ever view the star as it appeared 4 years ago, since even the light from Alpha Centauri takes more than 4 years to reach us. This immediately demonstrates that we are unable to see the cosmos as it is right now. In both temporal and spatial senses, we witness a play of light that consists of expansion and movement that occurred in the past. We can hardly ever see all the way to the edge with existing technology, and calculations are difficult because we can only ever see from Earth's perspective. You are undoubtedly aware of the fact that shifting your viewpoint or moving around the object you wish to identify can greatly improve your ability to distinguish ambiguous or indistinct objects. Regretfully, space isn't yet ready for that. We would need to either develop a form of clairvoyance that would enable us to see the entire cosmos, send probes to far-off locations in space, or enable spaceflight. Is it possible for us to transcend all boundaries? Do you recall the video's opening and our brief foray into the history of the planet Earth? How absurd the opinions of those from far ago seem to us now. It's likely that our descendants will have a similar opinion of us. They will likely be astounded at how unimaginative 21st century people were in their search for something outside of the cosmos and an edge to it. These individuals might live in a future where the multiverse is a fascinating and pervasive reality, rather than just a theoretical concept. The current theory holds that the multiverse is made up of numerous potential worlds, of which ours is only one. This theory states that either our universe would be inside another universe, or a new universe would start outside ours. The inhabitants of the future might even be aware that everyone has the ability to build entire universes and realities in a quantum multiverse. This would imply that our world's borders would vanish, and that there would be numerous universes and realities that just partially overlap and touch the one we currently refer to as Earth. The Everett. According to many worlds' interpretations of reality, we might eventually just manifest the limits away. Using only our imagination, we could conclude that the Earth is no longer a sphere and perhaps unite our globe with other worlds. According to this scenario, the end of the universe and what is beyond would have long since been resolved, and reality would just be an expanded and changeable mass. We shall eventually live in a world where the fundamental components of the cosmos are microscopic vibrating strings if string theory proves to be correct. At that point, the 4 known space-time dimensions would no longer exist, and our universe would have extra dimensions. There would most likely be additional dimensions behind what we currently believe to be the universe, whose appearance would be difficult for us 21st century Earthlings to comprehend. We enter realms of temporal, spatial, and dimensional infinity with each of these concepts. Nothingness is still a question. When we inquire about the edge of the universe and what lies beyond it, do you also instantly picture emptiness or vast emptiness? In actuality, these concepts go counter to the earlier notions, and this is quite normal. After all, it was long believed that the Big Bang was the end of the world. But as of right now, we know that nothing is impossible, and this has even been demonstrated at the quantum level. A state of complete force equilibrium is called nothingness. Quanta appear as particles and antiparticles in this emptiness, neutralizing one another to create no matter and no quantifiable forces. But in a strict sense, this is not nothing. Nothing at all emerges that we can now see. Everything has the ability to exist in this emptiness. Therefore, if there is nothing outside the bounds of the observable universe, this is a quantum fluctuation field from which, in some cases, a universe may emerge. This leads us back to the hypothesis of the multiverse. There isn't a huge void. As a result, the information always stays and must be preserved somewhere, just as our cosmos cannot just vanish after a fictitious conclusion. That's right. This brings us back to the previously undiscovered phenomena of the endless quantum fluctuation, which is nothing in mathematics and classical physics but includes everything. We must anticipate the existence of a brand new phenomenon that we are currently unaware of behind the universe's present edge. We might come upon a passage that might lead to another world, a sea of black matter and a dark cosmos, or perhaps a kind of enormous black hole. Imagine a point at which the laws that govern our universe abruptly change, or when matter abruptly becomes hazy. According to certain theories, the divine may reside there, or there may be an unbreakable wall at the edge of the universe. Others counter that our universe is a sphere and that we would always end ourselves back where we started, no matter how far we traveled or looked. Beyond the confines of our existence, there may be a vast energy network that provides power to humanity and even other dimensions and worlds. Alternatively, there might just be a wall at the universe's edge that reads, "Dead End." To stay up to date on all the latest video hits, click the subscribe button right now